So a little bit about your turn-in homework for lesson 4. This lesson and most of the lessons moving forward will primarily just be a paper copy. This is so you can show your understanding. You can show some work, proper notation and communication of these probability ideas. So I'll open up the PDF here. Here is a contingency table. So something to note. I want you to fully justify all of your answers. So, uh, so anytime you write a number that's not explicitly given, so if you are adding 90 and 44, you would get 134. But don't just write 134. I want you to say 90 plus 44 is 134. Right? That's what I mean by showing all of your work. Don't forget units. So just probability, I want both an unreduced fraction. So I can see, 37 over 150. I can now see explicitly what your numerator is and your denominator. No need to simplify it. Do simplify so it's a single term. Don't reduce it. You don't need to reduce your fraction. And then decimal rounded to 4 decimal places. So I want both the fraction and the decimal. So a bunch of different types of probabilities: conditional, intersections, unions, conditional probability, and finally an independence test. If you do not use an independence test, meaning you do 2 calculations and compare the values, then you will not get credit. I need to see those calculations. Now here's a deck of cards that is given to you for reference. And you are going to find the probability of a face card, find the probability of a face card given it was a club. What happened to that probability? What does that tell us? And are the events king and heart mutually exclusive? So do you know what mutually exclusive means? This table, this is thinking ahead to lesson 5, which is discrete random variables. So we're doing an experiment where we are rolling 2 dice, and then we're going to add the sums up, right? You're not actually doing this. We're creating the sample space for this experiment. If you want to Google sample space when rolling 2 dice, that's okay with me, right? The lowest possible sum that you could get is if you rolled 2 ones, so you could have 2. The highest possible sum that you could have is 12 if you rolled 2 sixes, everything in between. And consider every single possible outcome. So again, if you want to Google sample space for rolling 2 dice, that might help you see all of the different outcomes. So then the frequency is just how many times does a sum of 2 show up? How many times does a sum of 3 and 4? And then the relative frequency is what percentage of the time would I expect to roll a 2 or a 3 or a 4, for example, right? Are all of those sums equally likely to be rolled? What's the most likely outcome and what is the least likely? And finally, a question about a 2-step process pulling M&Ms from a bag. If you want to draw a tree diagram, it might help you keep in mind, order mattering, order not mattering, and thinking of an easy approach to some of these problems. There might be an easier way than kind of the direct calculation. Either one is fine, but again, show your work. Here, write percentages with 2 decimals. So don't just get a decimal. I want you to then convert it to a percentage as well. Right? Show all of your work and let me know if you have any questions.